Hi guys, how are you? Welcome to my YouTube channel, Field of Science. Today we are learning about Physics Class 11 Motion in a Plane chapter. You may expect 1 to 2 questions from this chapter. चलो हम start करेंगे without wasting any time. First we want to first concept vectors. There are several types of vectors. First, parallel vectors. If two vectors are in parallel in same direction, then they are called as parallel vectors. Second, anti-parallel vectors. If two vectors are in parallel but in opposite direction, then they are called as anti-parallel vectors. Then we move on to equal vectors. What is equal vector? Two vectors have same magnitude and act along same direction, then they are called as equal vectors. Next, fourth, coinitial vector. Two or more vectors started from same initial point. From here, if two or more vectors started from same initial point, then they are called as coinitial vectors. Collinear vectors. Two or more vectors acting along same straight line, like this, then they are called as collinear. Sixth, coplanar vectors. Two or more vectors lying in a same plane, means this is on plane, this is on plane, this is on plane, this is on plane. Two or more vectors acting in a same plane, three vectors in same plane, then they are called as coplanar vectors. Then we move on to null vector. What is null vector? The vector whose magnitude equal to 0, then they are called as null vectors. Negative vectors. Two or more vectors having equal magnitude but in opposite direction, then they are called as negative vectors. Unit vector. What is unit vector? Unit vector means the vector whose magnitude equal to 1, then it is called as unit vector. So next we move on to parallelogram law of vector addition. Draw a parallelogram by vectors. This is p vector, this is q vector, and the resultant vector should be r equals p plus q, which is called vector addition. The resultant of parallelogram will be r is equal to root of p square plus q square plus 2pq cos theta. Then we have to find the direction, means alpha. And what is the formula? Tan alpha equals q sin theta by p plus q cos theta. There are several cases in parallelogram law of vector addition. Case first, if theta equals 0, then r equals p plus q. The direction will be 0. In case 2, if theta equals 180 degree, then resultant is equal to p minus q. Then direction tan alpha equals 0. Case third, if theta equals 90 degree, then resultant is equal to root of p square plus q square. Direction tan alpha equals q by p. Then case 4, if p equals q, then resultant equals 2p cos theta by 2. Then direction tan alpha equals tan theta by 2. Alpha equals theta by 2. Case 5th, if two vectors are having angle greater than 90 degree, then resultant would be root of q square minus p square. Then direction or theta can be found by cos theta equals minus p by q. Next we move on to vector subtraction. Here in vector addition, the vectors are added, but here in vector subtraction, the vectors are subtracted. Here the resultant would be s is equal to root of p square plus q square minus 2pq cos theta. The only change in formula of vector subtraction and vector addition is minus. Then direction will be found by tan alpha equals q sin theta by p minus q cos theta. Here minus will be changed. Next concept, triangle law of vector addition. Here p is q, then resultant would be p plus q. Resultant would be p plus q. For polygon law of vector addition, consider the polygon. Here all are vectors. This is resultant vectors. Then resultant vector should be all sum, means p plus q plus s plus t plus v. Then we move on to relative velocity concept. Relative velocity means two velocities are subtracted. If v a b, then va minus vb. Some cases are there. Let's study. Case first. Two bodies moving in same direction means theta equals 0. Then here, if same direction means the velocities must be subtracted. Case second. If two bodies moving in opposite direction means theta equals 180 degree. Here, opposite direction means we have to add the velocities. VAB equals VA plus VB. Case third. Two bodies moving in perpendicular direction means theta equals 90 degree. Then on solving, velocities VAB equals root of VA square plus VB square. Next we move on to man in the rain concept. The problems are also asked from this concept. There are several cases. Let's study. Case first. If rain falls vertically downward, means this is velocity of rain vertically falling downward. This is velocity of rain with respect to man. This is velocity of man. But we are taking this as minus Vm because in opposite direction. So this is velocity of rain with respect to man. The angle between velocity of rain with respect to man and the velocity of rain is beta. The alpha is the direction. Then velocity of rain with respect to man can be found out by the formula Vrm is equal to velocity of rain minus velocity of man. We can find direction by using these formulas by sine and cosine and tan alpha, tan, and the beta can be found by these formulas. Case 2. If rain falls with some angle theta with vertically. In that some 2 points are there. First A, man walking. If man is walking, see here, velocity of man. This is velocity of man. The velocity of rain is some angle theta with vertical. And this is what velocity of man. Velocity of rain with respect to man. Vrm. Velocity of rain with respect to man. The angle between the velocity of rain with respect to man and the vertical is known as beta, means angle. Then how to find it? Using this formula, tan beta is equal to x minus Vm by y. X means the distance between the vertical and the man, and y means the distance between the man and the ground and the rain falling from y. Then we can say that tan theta, if you want to find theta, the angle theta means tan theta is equal to x by y by the Pythagoras theorem. Tan theta is equal to x by y. Then tan beta, if you want to find beta, then tan beta is equal to x minus 1. What is this? X minus Vm. So x minus Vm by y. If you want to, man is running, means this is velocity of man. This is velocity of rain, making some angle theta. If man is running, the rain with respect to man, it falls vertically. Remember, if man is running, then the velocity of rain always falls vertically downwards. So the angle beta will be 0. So that tan theta equals Vm by Vrm. So it falls vertically. Okay, next we move on to riverboat concept. The questions are also asked from this concept also. There occurs first, if the boat moves in downstream, see here, this is stream, this is a river flowing downwards. This is velocity of river, velocity of water with respect to ground, and the distance. This is boat, velocity of boat with respect to water. How to find velocity of boat with respect to ground? By this formula. Here, velocity of boat with respect to ground is equal to velocity of boat with respect to water plus velocity of water with respect to ground. Here, relative velocity concept is does not used. Here, they are moving in the same direction, but here we have to use negative in case of relative velocity concept, but we have does not to use relative velocity concept because this is whole system, not an individual event. This is whole system, so we have does not use relative velocity concept. So velocity of boat with respect to water plus velocity of water with respect to ground. If you have to find time, time is equal to distance by velocity. How much velocity is traveling? See here, velocity this much. So distance by VW plus VWG. If we move on to point B, if boat moves along upstream, means upward, the river flowing this direction, but the boat is moving in the opposite direction, then what happens? Velocity of they are moving in opposite direction, so we have to subtract these values. Velocity of boat with respect to ground is equal to velocity of boat with respect to water minus velocity of water with respect to ground. Then we have to find time means distance by velocity. Velocity we know, so distance by VBW minus VWG. Then we move on to case 2. I'm sorry guys, here so rainy so that the voice is very rough. Let's continue. Case 2. Boat crosses the river by short distance. Means here, this is river. It is flowing in this direction. But we have to move from A to point B by shortest distance. Means shortest distance is this. But the river flowing means in this direction. We can't go by here. If we started from here, then we move here. So we have to move in this direction so that we can reach here. So this is velocity of boat with respect to water, and then we move here. So velocity of boat with respect to ground is this. The angle between this is known as theta, and the width of the width is known as d, distance. This is velocity of water with respect to ground. Then how to find the direction? Theta, angle theta. Tan theta is equal to velocity with respect to ground by velocity with boat with respect to ground. Then how to find time? Time is equal to distance by velocity. Distance by velocity. Which velocity you have to take? The velocity which is parallel to distance. The velocity which is parallel to distance, that velocity we have to take. D by V velocity of boat with respect to ground. According to Pythagoras theorem, velocity of boat with respect to ground, we will get as this. So distance by root of VBW square minus VWG square. Then case 3. Boat crosses the river in shortest time method. Means if we start from here, if we travel from this direction, then we move here, but it needs shortest time, but it is lengthier distance. Okay, this is velocity of boat with respect to water. This is velocity of boat with respect to ground. This is velocity of water with respect to ground. This is point B. Okay, this is point B. Then this is distance. Then how to find this angle? Tan theta is equal to velocity of water with respect to ground by velocity of boat with respect to water. According to tan theta is equal to opposite by adjacent, this formula. Then how to find time? Time is equal to distance by velocity. Which velocity we have to take? Which is parallel to distance. See here, velocity of boat with respect to water. See, d by VBW is equal to d by root of VBW square minus VWG square. Then case 4. See here, this is velocity of boat with respect to water sin theta. This is velocity of water with respect to ground. This is velocity of water with respect to ground. This is theta, velocity of water with respect to water. Velocity of boat with respect to water. This is velocity of boat with respect to cos theta. On splitting it, we will get this. If see here, if velocity of boat with respect to water sin theta is greater than velocity of water with respect to ground, this. If this is greater than this, then boat reaches A. Then boat reaches A. See at this point. If velocity of boat with respect to water sin theta is equal to velocity of water with respect to ground, if this is equal to this, then the boat reaches point B. Boat reaches point B. If velocity of boat with respect to water sin theta less than velocity of water with respect to ground, if this is less than this, then boat reaches C. Okay, C. Then this drift x will be get as x is equal to v velocity with respect to water, velocity water with respect to ground minus velocity boat with respect to water sin theta whole into tan. Next we move on to projectile motion. There are two types of projectile motion. One is oblique projectile motion and another one is horizontal projectile motion. First one is oblique projectile motion. See from here, this is x-axis, this is y-axis, this is x-axis. The body is projected from here and it reaches here. This is the maximum height and this is the distance traveled is range. The distance traveled is range and this is u sin theta. This component is u cos theta. If this is velocity u. Along x direction, ux is equal to u cos theta. So ux means distance by time, x by t is equal to u cos theta. Along y direction, uy equals u sin theta. So s equals to, if this value is applied in s equals to ut plus half gt square, then y equals to u sin theta t minus half gt square. Minus means it is in opposite direction with respect to gravitational force. So then y equals to u sin theta t minus half gt square. In previous page, what we get equation 1 and equation 2. By this equation 1 and 2, we will get the formula as y equals to tan theta x minus g by 2u square cos square theta into x square. This is in the form of y is equal to ax minus bx square. If you want to find the value of a, if in question there is the equation like this, you have to find easily by this formula. Means a, what is a? A equals tan theta and b equals g by 2u square cos square theta. This is also very important formula in this chapter. Then next, how to find height. Maximum height equals u square sin square theta by 2g. There are some derivations how this get, but we don't need that and all, so we just remember the formula. Okay, h is equal to u square sin square theta by 2g and maximum height is equal to u square by 2g. Next, time of descent or time of ascent. Time of descent means coming down, time of ascent means going up. Then these both are same, u sin theta by g. Then time of flight. Time of flight means both time of ascent and time of descent. Here t, time of ascent plus time of descent means 2u sin theta by g. Next, fourth, range. Range means horizontal distance traveled by the object. Means r is equal to u square sin theta. R is equal to u square sin 2 theta by g. Maximum range is equal to u square by g. Next, we move on to very important note points. First point is h by r equals tan theta by 4. There are some derivation, but we don't need. We just remember these formulas. Okay. When will be the h equals r? When will the h height is equal to range? When the theta is 76 degree, then the maximum height is always equal to range. This is derived from this formula only. Next, second point, y equals tan theta into x into 1 minus x by r. Majority the formula, the questions are from this formula only. Here x means some height, r means range. Okay, remember this formula, it is very important. Next, we move on to horizontal projectile motion. From this diagram, this is the top of a tower. Okay, here body is projected, it comes to and reach here. This is velocity component x-axis, velocity component y-axis. This is h and this is y and this is x. This is whole range. X equals u into t means distance is equal to velocity into time, means x equals u into t. Then y equals half gt square. From the formula, kinematical formula, say s equal to ut plus half gt square, we can get this formula. See, this formula also derived from this only. Y equals g by 2 square into x square. This is very important formula. Next, what is time of ascent? And no, there is no time of ascent from here, only time of descent. What is time of descent or flight? These are both are equal because only time of descent works. Time of descent is equal to root of 2h by g. Remember this formula also. Second, range. Range is equal to u into root of 2h by g. Okay, just multiply u to this time. Okay. So I hope that you all got what I taught today. Thank you so much. If you want my short notes, please subscribe and just follow and message me on Instagram or Facebook. We will help you there. At filmistar789 Instagram and Rohita in Facebook. You can ask there and you can comment what is your doubt. And don't forget to like and subscribe. If you like the video, then it will advise it to another person so that he can get help from this video. Thank you guys. Bye bye.